solving quadratic trig equations, how do you solve, like if these were x's, how do you solve for x? X equals x, where x is the right answer. Okay.
X equals square root x.
How did you solve quadratic equations in grade 11? You had to make one side equal to 0, and then you factor, right? Complete in the square. So how do you factor something like that with the x's? You take out a common factor of x, and then you would know x could be 0 and x could be 1. Now, before we get into the trig, we're going to do a little bit review of factoring. Okay? Do you know why you factor to solve a quadratic? Or is it just something that you now do? Something that you do? So I'll give you a little, we're going to split the class in half, and we're going to have a speed. Oh, maybe we won't do speed. Okay. We'll do speed guessing.
Okay.
Or speed, it's a little bit of calculations. Okay? Okay. This half, you just have to tell me, I'm going to do some math in my head. Okay? And you just have to tell me what one of the numbers in my head is. And if you get it right, your team wins. Okay? And I'll do the same thing over here. I'm going to give you some math, some calculations to do that I did in my head. I'll give you the answer, and you just have to tell me what one of the numbers is. Okay? This group, I have two numbers in my head. I added them together, and the answer was 0. You can start saying answers whenever you're ready. This side, I have two numbers in my head. I multiplied them together, and I got 0. So you just need to tell me what one of the answers. Okay, you guys had a head start. They already got it. I gave you, I noticed the looks on your face. I thought, okay, this side's a little slower. I added two numbers in my head, and the answer was... No, that's not the right answer.
What if it was 2 and -2?
It wasn't 2 and -2. It was 7.2 and -7.2. Okay. It could be, exactly. It could be anything. And Hannah's onto something. You would have to like basically guess and check forever, and you would never know like what that would. It's really long. But what did I give this side of the class? Multiplication. And the only way to multiply and get 0 is if one of the numbers is 0. Okay? Or you round poorly. Okay, no. So your other number was 3.7 and 0. But you got the 0. You just needed to get 1. That's why we factor. This is the reason behind factoring. In the first stage, oh, we're subtracting two numbers and it's equal to 0. How long are you going to have to guess to figure that out? Like forever, right? However, as soon as we factor, we change adding and subtracting to something times something else. And when we do that, it means one of those two things has to be 0. Well, what happens if the first one's 0? What's x? Oh, it's 0. What happens if the second factor is 0? What does x have to be for this factor to be 0? X has to be 1. And boom, easy, we've solved it. So by changing from adding and subtracting to multiplying, that's the reason we factor. That's also the reason why one side has to be 0, because that property only works if it's 0. If I say I have two numbers in my head and they equal 1, what are they? Again, there's 33 and 1/33, but you would have to guess forever for that, because it could have been 3 and 1/3. But as soon as it's 0, something powerful happens. So that's why in quadratic equations, we make it equal to 0, and why we factor. Now, when you first learned factoring, you were probably explained this, but you just weren't ready to fully understand it. Does it make sense now, though? Okay. So, now we're dealing with cos instead of x's. Notation-wise, we've already seen if you want to square cos, you put the squared between cos and the theta. And so if I wanted to factor this, I could say, oh, there's a common factor of cos. I factor that out. Here I'd be left with cos theta minus 1 equals 0. Here's my multiplication right here. So either the first factor equals 0, in other words, either cos of theta is equal to 0, or what would make this one equal to 0? When cos of theta is equal to 1. Is that on your pie plate? Yeah. Is the x-coordinate ever 0? When? 0? When else? No, at pi it's, yeah, is it 0? For your, no, wait a minute. This is our x, cos is our x-coordinate. At 0, our x-coordinate is positive 1. 90 degrees, which is in radians, pi over 2. Anywhere else? 3 pi over 2. Is cos theta ever equal to 1? Where is that one? 0. Why wouldn't I get full marks for this? Because I didn't make my 0 nice enough? No. 0 radians, which is good because my domain here is in radians. So I have to, it could also be 2 pi. And my domain includes 2 pi, so my answer has to include 2 pi. Okay? Your textbook does this sometimes. Your textbook sometimes does stuff like this. So then this would be wrong because I included 0, and they didn't include 0. Oh. Yeah. So, right? Go home, take a butter knife, stab your textbook once.
That's what you get.
That's what you get. Or if you want to damage its inside, actually take butter and smear it and squish it. It's like seep through the pages and ruin a bunch of it. How did you solve quadratic equations when there was just, if there was just an x squared, what did you do? Did you factor? Or you put it to the other side and square root both sides? Awesome. So we could do that. Oh, I want to do something else, but I'm not. Okay, I'll do it nice. I'll be nice. I'll do something else in a bit. Okay? Sine squared minus 3 over 4. So I'm going to move the 3 over 4 to the other side. How do I get rid of a squared? Square root. What mistake did I make? Positive or negative? Right? Can you see yourself, oh, I'm going to make that mistake? Can you simplify the square root of 3 over 4? It's the square root of 3 on the top over the square root of 4 on the bottom, which happens to be 2. Right. Is that on our pie plate? What's our reference angle? Pi over 3. And since we have plus or minus, we would have all 4 quadrants. So we would have the whole family come out. Pi over 3, 2 pi over 3. Family reunion, yes. Good times, or depending on the family, bad times. We'll never know, right? Family reunion, everybody together. Fireworks sure to happen. Now, you ready to get a little, just a tiny bit abstract?
Is there a better way to do it?
No, I like this. Okay. Normally, if I said, can you factor that? You would say no, right? Can you factor this one?
Yeah.
Right? Why? Yeah, they're perfect squares. So why don't you just expand your mind a little bit and factor this one? X times x is x squared. What times what is 3? Root 3 and root 3. And if I had 3/4 here, over 2 over 2. 1 plus 1 minus. Oh.
Mind blown.
Cool. So you can factor things that couldn't be factored before if you just expand your rules a little bit.
But you can also just do x equals the square root.
Well, that's what we did, right? We moved things over and square rooted. And that's probably the best way to do it. But had I wanted to at the beginning, I could have factored this to be sine theta and sine theta, 1 plus root 3 over 2, 1 minus root 3 over 2. And I would get both the plus or minus and get the whole family reunion that way too. Okay. Ooh. Now, generally what happens in grade 10 and 11 for factoring, as soon as there was a number out in front, your confidence went down and the factoring got harder.
Yeah.
Okay? And there's like, you learned a grouping, you've maybe learned a grouping method that you've since forgotten, or maybe you didn't forget. Okay? Now, for most of the factoring that we're going to do in grade 12, I'm going to revert you back to a basic form of factoring. Okay? What is factoring? Like if I wanted to factor something, like for example, if I have 2x minus 1 times x plus 5, if I multiply that out, you see that you're going to get 2x squared. Mental math-wise, are you okay if I do this next step and go minus 9x minus 5? How do you multiply? What's the acronym you use to remember how to multiply something like that? FOIL. Okay? And the first ones always give you this one. I want you to notice that. And the last ones always give you the last term. But the outside and the inside were always like terms. Can you see that? That when I do my outside here, I get positive 10. Oops. Da, 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 da. When I do my outside, I get positive 10. When I do my inside, I get minus 1. And my outside and inside always have to combine to do that. FOIL. So when I'm factoring something like this, I want you to go directly to this. If the first ones have to be this, what's my only possibility for my first ones with whole numbers? Can you see that the only possibility is 2 and 1? It can't be anything else. Sometimes they're harder. If it's a 4, then you have 2 and 2 or 1 and 4, a little bit harder. But for the most part, the ones in grade 12 are going to be easy like this. There's only one choice. It has to be 2 sine theta and 1 sine theta. I then look at my last number. I get a 1. With whole numbers, what's my only possibility? 1 and 1. This is like the easiest factoring I've ever done. I haven't had to do any thinking so far. Now the last part is where the thinking comes in a little bit. We need the outside and the inside to combine to get minus 3. And we have to decide on what signs are going to go in there in the middle. Yes? Mm-hmm. Because this will be faster. Okay? I mean, but if you want to go back, if you want to do the grouping method, that's perfectly fine. But at times, the thing is this is going to be one step in 15 other steps in a question. And you want just to have here and the next answer factor it without having to do a bunch of extra math. Also, sometimes in the grouping method, students are prone to putting the brackets in the wrong place, and then you've got a deduction for a mathematical communication. Anyways, I need a -3.
Hello?
Hello?
We've been talking with JR. Could you have
So to get a -3 using the outside and the inside, they both have to be negative. And if I do a quick check, are my last ones still +1? Yes. So that allowed me to factor it. And now that I've factored it, well, here, sine theta could equal 1 to make that one 0. What would make this one 0? Okay? If you can't see it right away, set up a little equation for yourself. If this whole thing has to equal 0, what would I have to do? I'd have to move the 1 over and divide by 2. Oh, sine theta would have to be 1/2. For most of you, after a week or so, you're going to just do that sine theta equals 1/2 directly. Are those values on our unit circle? What's our reference angle for this one? Pi/6. So what's our answer going to be for this one? Quadrant 1 and quadrant 2. 1 is on our axes family. When is your y-coordinate equal to 1? 90 degrees or pi/2. Nice. Okay, just a little, before we go into this one, just a little bit more factoring. So this one looks hard to factor. In reality, it's not that bad. Because if we do it directly, the only way we can get 5x squared is 5x and x. The only way to get 7 is 1 and 7, or 7 and 1. And now it makes a difference, because if I do 1 and 7, or 7 and 1, can you see that they change my outside and inside? Which is the right one, the red one or the purple one? Purple. If I use the purple, my outside is 5, my inside is 7. 5 plus 7 equal to 36. 5 times 7 is 35. So it has to be 7 and 1. Because now my outside here is 35x. My inside is 1x. They would both have to be positive to get positive 36x. Yes? So this method is just thinking about FOIL. It's looking at patterns when I multiply something like 3x plus 7 times x plus 3, and I multiply that all out, I'll get 3x squared. Here I'm going to get 9x plus 7x, be plus 16x plus 21. Okay? That's multiplying it out. If we want to factor, factor is the reverse. It's like dividing. It's undoing the multiplication. So what we do is we say, I notice that my first ones always match up with those two multiplied together. I notice that my last one always matches up with those two. My outside and inside combined have to give me 16. That's what I'm going to look at last. If my first one is a prime number, like 3 is, when I go to factor it, the only possibility has to be 3x and x. And then, with my last number being 21, there's some options here. 7 and 3, 3 and 7, 1 and 21, 21 and 1. So you have to start to think, well, what might work? So we know that it's going to be 7 and 3, but let's say you thought it was 3 and 7. Quick check on my outside. My outside's 21, my inside's 3. Does that ever make 16? No. So we want that to go away. If I chose 7 and 3, now my outside is 9, my inside is 7. And when I multiply that out, I get 16. They would both have to be plus to get plus 16. And if they're both plus, I still get plus 21. So it's just undoing how we normally FOIL. Yes? This one must be hard because there's a hint. Now in grade 11, you did questions similar to this, right? If I asked you to solve 3x plus y equals 5, what's the answer? I want everything. Can you solve for x and y? Is there just one answer? No, we have a problem here because we have two things we don't know, but only one equation. If I gave you a second equation, you remember this? If I tell you, oh, also minus 3x plus y equals 1, then you could solve it. Maybe you used, in grade 11, do you remember the elimination technique where you added things together and you're like, oh, so 2y is equal to 6, so then y is 3, and if y is 3, what would x be? Negative 2/3. Okay? So there was that kind of thing in grade 11. When you just have one equation with two things you don't know, there's more than one answer. You can't solve it. In fact, in this case, the answer is a line, y equals mx plus b, with every single point on that line would work. So now I have an equation, negative 3 sine theta minus cos squared theta. And if we think of cos as sort of being our x coordinate and sine as being our y coordinate, this is kind of like trying to solve this. And we run into a problem because we have two variables and we can't solve it. But if we use our big idea, we have a second equation. And in grade 11, when you had two equations with two unknowns, you either used elimination or, do you remember the other technique? Substitution. And so what we're going to do in these questions is we are going to use substitution. And the only thing you can substitute is something with the squared. In this case, I have a minus cos squared. If I go to this equation, could I get cos squared by itself? Yeah, I could just move the sine squared over. And now I can rewrite my original equation, negative 3 sine theta minus, and instead of writing cos squared, I can now write and substitute in 1 minus sine squared. Combining my like terms, distributing that negative, I would now have positive sine squared minus 3 sine theta, and the minus 1 and the minus 3 go together, and I get a minus 4. And now I have only one trig function. It's like having only one variable. Now I can factor. Sine theta and sine theta. This is easy because it's sine squared at the beginning. That's the only thing that's possible. For 4, it's either 1 and 4 or 4 and 1. Okay? It doesn't matter because both of them are sine theta. Can you see that your outside is 4? Your inside is 1. I need to get a negative 3. My outside should be negative 4. My inside should be positive 1. Sine theta is equal to negative 1 here. Sine theta is equal to 4. Is negative 1 on our unit circle? Yes. When? Y coordinate negative 1. So negative 1 will be at the bottom, 3 pi over 2. Is 4 on your unit circle? No. Most of the time, when something is not on your unit circle, that means you have to go back to your old technique of finding your reference angle with your calculator and solving. However, this question is still non-calculator. Why is that? How can I do this? If it's not on my pie plate, how can I do sine of theta equals 4 without my calculator? Are we stuck? Should we draw a picture to help us? Okay. If I draw a picture, what is the definition of sine? Definition of sine is opposite over hypotenuse. So I'm going to draw a right angle triangle. I'm going to label my opposite side as 4 and my hypotenuse as 1. How do you feel? Why is that incorrect? Hypotenuse has to be longer. Can you draw a right angle triangle with the opposite side of 4? And, because that's what this ratio is, 4 over 1. Can I draw that? No. So this can be done without a calculator because the answer to this side is not possible. And the only answer to this one is negative 3 pi over 2.